Okay, welcome back everybody. Here is our problem. So let's see, so for the expecteds, again we have to calculate the expecteds always. So here we're going to take our percentage for each category and multiply it by our n to get the number in that category. So 0.60 times 300, n times p, 300 times 0.60, 180, 300 times 0.32 for 96, and then 300 times 8%. Remember, 8% is 8 cents, 0.08. Don't write it as 0.8. That will mess you up completely, right? So 8%, 0.8, just write it like 8 cents, 0.08 times 300, 24. Good. All right, and then my H naught, O sub I equals E sub I, that's my claim. H1 is O sub I is not equal to E sub I. And then my critical value. So I'm going to look it up on the table. I have 3 categories, right? So it's going to be degrees of freedom is 3 minus 1, which is 2. Alpha is 0.01. If you look that up, you will end up getting to alpha 0.01, 9.210. So 9.210, again, steep up and then slip off gently, draw your other line, shade to the right, 9.210, that's your critical value. And then your chi-squared, it's super easy. So incidentally, you have to write this out on the exam. There's only going to be 3 or 4 of them. You need to write them out, or else you will not get full credit. You're going to lose a bunch of points on this one. So just write it out. My 152 minus 180 squared divided by 180. 120 minus 26 squared divided by 96. 28 minus 24 squared divided by 24. Just write them out. And this one was just as fast to do on the calculator, honestly, than it would be to make lists and do all of those stuff. So I just did them on the calculator quickly, added them up, got 11.02. You have to do this circled part. You have to show me that. That's your work. And you have to give me the answer. You don't have to do this part, this intermediate part down here in the bottom, but you do have to do this first part and this part here, the 11.02 for credit. And then pop it in where it goes. That's totally in the guilty area, so I reject H naught, which means I have enough evidence to reject the claim that the proportions are as stated. Okay, questions about this one? Anyone questions at all? Anybody still here? Is anybody here at all?
Yeah.
Okay. All right, good. All right, awesome. Thanks, guys. Great. Oh, yeah, and there it is. Showing you guys that part. All right, so now we are on to the next page. So if you flip over, so I think that page, the one we just did, the shopping bags, that's the one you're supposed to turn in for your work today. So this one we just did, which we did, the firearms we did last class. Oh, no, that's not true. That's not true. We're not doing that one at all. The one coming up is the one we're going to turn in for today. My bad. Ignore that. So now we're on to 11.2, contingency tables. Test using contingency tables. So it's the very next page. And most of what you're going to need is going to be about 2/3 of the way down. There's going to be stuff about like critical values are found using chi-square table with degrees of freedom equals parentheses r minus 1 times c minus 1. So that's the stuff that people are going to kind of feel like they really need, and that expected value is the row total times the column total divided by the grand total. Those are the stuff you're going to need when you get to the problem itself. So take note of that. All right, so contingency tables, there's going to be 2 types of tests, which are really the same test. The first one is a test of independence. So it's saying that the variables that are in your column and your row are independent of each other. And there's a homogeneity of proportions test, which is a test to say that the proportions in each of your columns are the same. And these guys are the same test. Because if you guys remember from chapter 4, the test of independence to see if 2 variables are independent or 2 things are independent was to see if the proportions were the same. If the proportions are the same, then they're independent. So we'll talk about that in a couple of minutes. But first, let's define a contingency table. It is a two-way frequency table. In other words, it has two variables. Now, you remember from Chapter 10, Chapter 10 had two variables also. Like we had casino size in square feet and casino income. But those two variables had numerical data, right? Size of casino in square feet, those are all numbers. These ones are two variables that are categorical. So it'll be things like, with our puppies, the puppies in the shelter, we had Labrador puppies. So type of lab, right, yellow, chocolate, or black lab, and then the gender, male or female. So those things are not numbers, it's categories, labels, right? I'm a chocolate lab, or I'm a yellow lab. Okay, one of them is for the rows, the other one is for columns, and then you end up with those tables like we had in Chapter 4. You have to have at least two rows and at least two columns, right? At least two choices for each one. All right, so here's an example of one. You can see that there are 4 different options for someone, treatments for someone who breaks their foot, and then based upon what they got, they could either have a successful or a failure for their treatment. Either it worked or it didn't work, and it could end up in one of these categories, one of these 8 slots, kind of in a way, right? Okay, great. This is the one that we should be familiar from Chapter 4 completely. So, for example, my next door neighbor's dog is a black lab. Smokey is male, so he's going to be counted in this group here. He's one of those 13. So these are all just categories, right? What kind of black lab, or what kind of lab is he? What gender is he? And these are all just going to be tally marks. He's going to be one of the tally marks in that group. Okay, now, what we're going to do is, if you guys remember, say we want to see if male labs and black labs were independent of each other. So we take the ratio, we take the black males compared to just the total black labs, and then the total male labs compared to the total labs, which is down here. That would be, that was 40, right? And then we compare them. We compare those proportions. So we do 13 over 23 and see if it's equal to 25 over 40. And it isn't, which means that they're dependent. I know it matters whether you're male or female to tell you what the probability that you're a black lab. So that's what we did before. But that was just between two different labels, between black and male. Now we're looking at the entire variable of type of Labrador and the entire variable of gender, and comparing those two things to see if, in general, because here you can see, like, if I did chocolate and male, 5/8, 5/8 here, and 25/40 there, those would be equal. So chocolate and male, those are independent, but black and male aren't. But now we're going to look at the whole thing to see if all of them are independent from the gender. So what we're saying is that if we take 5 over 8, the ratio is 5 over 8, that should be equal to 15 over 24, which should be equal to 10 over 16, which should be equal to the total, 30 over 48. And in fact, they are. These are all equal to 6.25. And you could have done the ratio of female to total as well, 3/8 and comparing to 9/24 compared to 6/16 compared to 8/48, you get the same thing. Or you could have compared male to female ratios. Any one of those proportions actually works. They all work out to be the same as each other. And so these ones would be, then we would say that gender and color are independent. Doesn't matter what gender you are, it's independent. It won't give you any information about whether or not you are, you randomly pick a yellow lab. No matter what, the probability to pick a yellow lab is going to be the same, whether it's male or female, and vice versa. Now, in reality, even these proportions are the same. In reality, you take a sample, it's always going to be off a little bit. Right? It's never going to match up perfectly with the population. So we expect some of these numbers to be off a little bit, when we take a sample. Like this might be 4. This might be 4. This might be 16. This might be 8. Right? The question is it off? The amount that it's off, is it, close enough to say that there's still, the proportions could be equal? Or are they so far apart that there's just no way? And that's what we're going to be looking at in this test. All right, so here's some familiar notation. O again represents the observed frequencies, E represents the expected frequencies, and then R represents the number of rows you have. All right, so this last one, we had male, female, we have 2 rows. Chocolate, black, yellow, we have 3 columns. So C is our number of columns. We have 3 columns here, chocolate, black, and yellow. So again, that makes sense, right? C represents the number of columns, R represents the number of rows. So this is our test. We're going to start in with this H naught. Again, H naught is always no or equal, no difference or no relationship in this case. So, or you could say that the proportions are the same. In other words, the first proportion equals the second proportion equals the third proportion equals the fourth proportion, however many proportions you have. Right? So, or generically, so you could do either one of these depending upon the situation, the wording, or you could just use the generic one. So for all of 11.2, I will let you use on the exam O sub I equals E sub I. The homework will make you spell it out a little bit more clearly depending upon, and we'll give you other options. You have to pick the correct one based upon the wording, and that's going to kind of vary. But again, you should remember that H naught is always no something, or equals. And H1 would be the opposite. So H1 would be, if H naught is no relationship, then H1 is a relationship. If H naught is proportions are equal, then H1 would be at least one differs. If H naught is O sub I equals E sub I, then H1 would be O sub I is not equal to E sub I. Okay. Okay. So we're going to make a contingency table, and again, our degrees of freedom, if you look down at that 2/3 of the way down your page, you're going to see it's your number of rows minus 1 multiplied by your number of columns minus 1. So R minus 1 in parentheses times C minus 1 in parentheses. Find those 2 amounts and you multiply them. It's a little bit tricky, guys. Don't forget that. Degrees of freedom, it's a little bit weirder, more unusual. And then our test set is exactly the same as before. Right? The sum of our O minus E squared divided by E's for every category. Our expected frequency, expected values are going to be, it's our row sum times our column sum divided by the grand total. We're going to go over that in a couple of minutes. But let's move on to the test stat first. So I will make you find your expected values, but not all of them, just the first one and the last one by hand to prove to me you know how to do it and where those calculations come from. The rest of everything you can do using the TI calculator. It's going to be super, super straightforward. You're going to put your observed into matrix A, and then you're going to do stat test chi-squared test. And then it's going to bring up this, and you're going to put in A for your observed, which will probably already be there, B for your expected. The A's, you have input your observed into A's. B's can be whatever, because stat test chi-square test is going to overwrite whatever is in B and store the expected values into that matrix. It will output them and write them into that matrix B. You don't have to do anything to B. The program itself writes stuff into B. It will also give you your chi-squared value and your p-value. Remember, p-value is the probability of getting a sample like yours. It's unlikely or likely. All right, so here's an example, a kind of more concrete thing. This is the page that you are turning in now. So this one is hospitals and infections. So a researcher wishes to see if there's a relationship between the hospital and the number of patient infections. So first let's take a look at this, and you guys tell me how many rows and columns there are. Private text me, private chat me. How many rows and columns do we have? How many? I'm waiting to hear from you. How many rows and columns? How many rows? How many columns? Privately. Oh, did I not tell you about the RC? So it goes RC is how you do it. So R by C, so row by column. So I've heard from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people, no, 10, 11 people, 12 people. Okay, that seems good. All right, so here we have, don't get confused, look at our data. We have type of inspections. We have 1 surgical pneumonia bloodstream. We have 3 of them. We have hospitals. We have 3 of them. These guys here are totals. Don't count the totals. Those are just totals, totaling things up. They're not actual data. Our actual data is this right here, this 3 by 3 matrix. So let's say 3 by 3. 3 by 3. Good? And again, it goes rows, then columns. RC. I remember that by RC Cola. When I was a kid and I was learning matrices, RC Cola was big. So we'd always have these commercials on about RC Cola. I don't know, some sort of frosty something. I don't know, maybe, I don't know what it was. But RC Cola. I think it had a guy dressed up as a king or something. At any rate, RC. So row, then column. So 3 rows, 3 columns. So here's our first one. I'm going to state the hypothesis, identify the claim. You could just be super straightforward and simple. O sub I equals E sub I. H1B O sub I is not equal to E sub I. The homework is going to make you be more specific. So if you read through the problem, it says, talks about independence, if there's a relationship, right? So it's going to be more specific on your homework. And it's going to say the number of infections is independent, no relationship, of the hospital. So independent means there is not a relationship. No relationship, no. Right? So like me, I have no relationships. I'm very independent. I do not want to compromise, none of that. So no relationship, I'm independent. So that's kind of how I remember it, right? So that's H naught. You are independent. You have no relationship. H1 would be that it is dependent. There is a relationship. It's related. So your homework is going to make you be more specific about that. For me, on the exam, I am just good with O sub I equals E sub I, and O sub I is not equal to E sub I on the exam. But for the homework, you're going to need to be more specific. Okay. I asked what RC Cola is. I'll show you guys. One of my students actually brought in a can of it a couple years ago. I've got it in my car waiting for you guys in the trunk, but I'll pop it out now and bring it out next class. All right, next, find the critical value. So remember, this is that weird one. We have to take R minus 1, my rows minus 1. I have 3 rows, so 3 minus 1, that's 2. My number of columns minus 1. I have 3 columns, so 3 minus 1, that's 2. So 2 times 2, 4. My degrees of freedom is 4. So alpha 0.05, degrees of freedom 4 on my table. I'm going to get 9.488. So again, steep up and then slope off. Shade 9.488. This is the example. Yeah, the next page. This is the example. You should be filling this out. This is what you have to turn in today. So you should be filling this out here. So which means I should probably give you guys 30 seconds to fill this out. Right here, the very first thing on the next page, the example. Alpha. Whenever alpha is not stated, then alpha is 0.05. If we don't give you alpha, then you should always assume that alpha is 0.05 because generally speaking in statistics, what's our guideline for unusual? Typically 5% or less. So that's our alpha, typically 5% or less. Okay, good. So you guys should have this copied down at this point. Critical value, right? 3 minus 1 times 3 minus 1 is 4. Degrees of freedom is 4, and then look up your critical value, 9.488. Alrighty. Good. So then we need to find our expected values. I only make you find two, the first and the last. My first year or two, they had, those poor students, I made them do it all by hand. They had to calculate every single one of these, and then do all the, I'll show you guys what they had to do. All right, so, but here, I'm only going to make you do the first one and the last one. So again, remember my data is right here. This 3 by 3 here, that's my data. So we're going to take the first one is 41, the last one is 109. Oops, wrong way. Wrong button. Oh, and I went the other way. Darn it. Okay. So 41, my first one, I'm going to find its row total over here, 119, and its column total. It's in column 1, so the column total is 246. So 119 times 246 divided by the grand total, 582, divided by 582. I'm going to get 50.03. So that's its expected value. I got 41. I expected to get 50.3. Then I'm going to do it for this last one. So its row total is 384. Its column total is 200. So 384 times 200 divided by the grand total, 582, is 132.0. So 132 or 132.0. Give me at least 3 sig figs there. 3 sig figs is good. And this first one is the first row, first column. So it's expected value. This is what we call it, big E, 1, 1. The expected value for the first row, first column, E11. This one up here is the expected value for the third row, third column. So it's big E, 3, 3. That's how you write it, the expected value of the third row, third column. Okay, good. And again, it's the row, you find its row sum and its column sum, multiply them, and then divide by the grand total. Doesn't matter which one you do first. You can do, 200 times 384, 384 times 200. It's, multiplication is commutative, so it doesn't matter. All right, so you found, I'm going to make you guys find just the first one and the last one, not all 9, just the first and the last, to prove you know how to do it. Used to be all 9, but first and last is, it shows you know how to find them, and just one might not show your depth of knowledge of how it moves around as you go around the matrix. So first and last, that's good. All right. So here is every single expected value and its observed value. So this is 41 is observed, 50.3 is expected. So this would be 41 minus 50.3 squared divided by 50.3. This one would be 27 minus 27.81 squared divided by 27.81. So you find all of these and add them all up, which looks like this. This is all 9 of them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what my class had to do the very first semester. I no longer make you guys do that. So instead, you do not have to do this. Instead, you can just use the calculator. But if you did do this, you'd get 30.698, which you're going to see is what we're going to get with a calculator as well. So this is what we're going to do. Everyone get out your calculators, get them out, turn them on. And we're going to do matrix edit A. And then we're going to put in our rows and columns. In other words, this is a 3 by 3. You guys see it's 3 rows, 3 columns, 3 by 3. So matrix edit A. What does that mean? That means we're going to go to, turn it on, clear. All right, so second, and if you go down to the fourth one down here, you see the little matrix in blue right here in the corner? Hit that. So second matrix, again, second matrix is what brings us up, because it's the blue one up there. And then go over to edit. So right arrow over to edit, and we want the first one, we want A. So hit enter on A. Now I want a 3 by 3 column, 3 rows, 3 rows, 3 columns. Yours probably says 1 and 1. So just type in 3, and then arrow over or hit enter, and then type in 3 there, hit enter, and all of a sudden, boom, it's going to give you a 3 by 3. And then put them in. So we have 41, 27, let me do that, 41, I'm not in here. 41, enter, and you see as I enter it, it goes off to the right. It's going to kind of swing around there. 27, enter, 51, enter, 36, enter, 3, enter, 40, enter, 169, enter, 106, enter, 109, enter. And then double check your numbers and make sure they're right. Because you messed this up and everything's going to be garbage and you have no idea that you've messed it up. Okay, and I won't know that you've messed it up because it's on the calculator, so I can't even give you partial credit I can't give you partial credit. It's all on the calculator. So that's the downside of this, is when it's on the calculator, it's way easier, but there's no partial credit. It's either right or wrong, that part of it. Okay, so double check. Mine looked good. Last class I had a little typo, so, and just, you can arrow up and over. If you messed up one, you can just, use these arrows to kind of get around this, to move around it. Okay, and you can use the up arrow. If you mistype the number of, say it's supposed to be a 4 here, you can use the arrow up and that'll get you, up and down arrows get you, from up and down from there. Okay, so everybody has your matrix in. Even if you don't, stop and look. Watch this. Just stop for a second and watch. So I'm going to do stat, test, and I'm going to arrow up to chi-squared test. Up a few to this chi-squared test right there. Not the GOF test. 83s, you're only going to have this one test. 84s, you'll have both of them. You may have both of them. That would be for the 11-1, which you're allowed to use. I just am not going to show it because 83s don't have it. But you're totally allowed to use it. You still have to spell everything out, though. You still have to write it all out. All right, so chi-squared test, hit enter, and it's going to say, oh, my observed. Yes, those are in matrix A. And then my expected are in B. So where'd he go? All right, so there's my matrix. I went to chi-squared test. So you're going to input, you input into A. It's going to calculate, and it's going to stick it into B, what it calculates. It's going to calculate the expected and throw those into B. And once you do that, it's going to give you this. It's going to, you hit enter, it's going to give you, hit calculate, it's going to give you this readout right there. All right, I'm going to go down, arrow down, calculate, enter, boom, there it is. And what's going to give you is the chi-squared, 30.696, which is what we saw on the last page. And it's going to give us our p-value. See what it says, 3.53? So let me ask you this. Is 3.53 my p-value? Everybody, private chat me, yes or no. Is my p-value 3.53? I need everybody's answer. Private chat, yes or no? 5 people, 6, 7, 8, 9, 10. Let's repeat. Okay, right, exactly. It's not. This is not it, because see that my p-value is a probability. I'm going to have a 353% chance. That doesn't make any sense. See that E -6? That means you have to add 6 zeros and then the 353 and put your decimal place after the first 0. Right, so this is not, anytime you have a p-value and you have a number larger than 1, don't forget, you better have an E negative something over here or something's very, very, very wrong. And that E means add that many zeros to the front of it and then put the decimal place after the first one. It also gives you your degrees of freedom, so that's kind of cool. Right, because degrees of freedom, in case you had trouble calculating or you forgot or you didn't write it down, it'll tell you degrees of freedom so you can find it'll help you find your critical value. It gives you degrees of freedom to find a critical value. Okay, do you want me to show you guys that in the calculator again? So again, it's second, and then down to matrix, down here, the fourth one down, go over to edit, hit enter, put in what you want, 3 by 3 in this case, so 3, enter, 3, you can either right arrow or you can hit enter, and then type them all in. You can arrow around if you want to, or you can just hit enter and it'll go across. And then hit stat, over to test, and then up to chi-squared test, or you can go down, but it'll take you longer. enter, observed A, expected B, and again, you're only going to input into A, it'll calculate the B, and then hit calculate, and you're good. Okay, so then make the decision. So here's my picture, 30.69A is way out here, totally in the rejection region, so we're going to reject H naught and summarize our results for the claim. There is enough evidence, so I'm okay if you just said this, enough evidence to reject claim that proportions are as stated. Or in this case, you might want to say proportions are equal, because that would be the same thing. Equal proportions mean, because proportions are always going to be equal here. It's not going to be some fixed percentage. So you can totally just do that if you want, because again, remember, equal proportions means that they are independent. They are the same thing. Are equal. I like that better. Equal. Okay, or you could do it the fancy way, the real way, and say there's enough evidence to support the claim because we claimed that they were related, that the number of infections is related to the hospital where they occurred. So here H1 was my claim. Your homework is going to make you do that. Your homework is going to make you pay attention to see if they're talking about related, it's going to be H1. If they're talking about related or not equal to, it's going to be H1, or dependent. If they're talking about independent or equals, then, or not related, or no relationship, then that's going to be H naught. So you just have to kind of work with that. I can go back a slide, sure. So yeah, go ahead and take a picture of that, or draw that out really quickly if you need to. That's step 4 in your example. So again, you should have your picture, and then it's just reject H naught. As long as you have your picture, that's all you need, right, with your shaded area. Check H naught. Give you guys 5 more seconds. Take a picture if you need to. 5, 4, 3, 2, 1. Okay, so again, here's your summary. And I want to point out something about p-values here, just so you have that to kind of prep you for what we're coming. Back to screen for solving E. To finding the E's. You guys are making me work now. So this was those.
Professor, so what work do you want to show? Is it that?
Yes, I need this. So everything that I've written here, you need to show me.
Okay.
Yeah.
Just for the first column and rows?
Yeah, the very first one in the matrix and the very last one in the matrix. First and last. I need this. So I need E11 and whatever the last row, last column is. Great questions, you guys. Okay, good. Okay, so I'm going to move on from here. Go and take a picture if you need it. Here we go. There's all of them. You do not need to write this down. So this stuff here, you don't have to write down at all, unless you want partial. I mean, unless you think you might screw it up, and that would be your partial credit. But yeah, you don't need to show it at all. Just check your numbers. Right? If you check your numbers, then you won't need to worry about the partial credit. And again, just put this into a matrix, and then do stat test chi-square test, and that is going to give you your p-value and your chi-squared value. And your degrees of freedom if you need it. And if you happen to go to matrix B, it would give you all of your, if I hopped into matrix B right now, on second matrix and went to B. Ooh, I don't know if this works. I think I've hit enter. Then yeah, here it is. So 50.3, that was my first expected, and my last one was, if I arrow all the way over, yep, 131.958, 132.0. So that's them. Okay. This one here, step 4. Come on. And then summarizing the results. Okay. So just to kind of give you guys a little bit of a heads up, just to remind you, one thing you might notice is that when your chi-value is really small, that means your p-value is really big. It's the opposite. P-values are the opposite, because remember, p-value is the probability. So in other words, when my chi-squared is small, then it's very likely I have a large p-value. When my p-value is really big, way out there, way out here, then it's very unlikely, so my p-value is going to be very, very small. It's the opposite. The p-value is right. The p-value goes the opposite of what the chi-value is. When the chi-value is big, p-value is small. And their phrase from the book is, if the p is low, independence must go. One of my other students came up with this. I think she got it from the book. But it's, if p is low, h naught must go. And that is good for all of the for all the tests. If p is low, h naught must go. Totally true. In other words, you're going to reject h naught if your p value is low. So I thought that was super useful. Okay, now you guys are going to do lab problem 2, sports preference. Let's get Angela, go ahead and read. Or Soraya. Soraya, you're open. Go ahead. Oh, Angela, yeah, Angela, go ahead.
Sorry about that.
Okay.
Lab problem 2, sports preference. A researcher wished to see if there is a difference in the favorite sport of males and the favorite sport of females. She selected a sample of 32 males and 48 females and asked them which of 3 sports was their favorite. The results are shown. Great.
So let me ask you guys, how many rows do we have? How many columns do we have? Everybody private chat it. How many rows, how many columns? Quickly. So let's spend all day. Remember, it goes RC cola, row then column. RC. Good. You guys seem like you got it. It's a 2 by 3 because we have 2 rows, male, female, 3 columns, football, baseball, hockey. R by C, RC. So you guys go ahead and work this out. I'm going to pop you into rooms. This is the other problem you're turning in today. So I'm going to open up the breakout rooms and you guys are good to go. Let's say 8 minutes should be enough for this. Should be probably less than that. Yeah, we'll do 8. Let me know if you guys are done before then, and maybe we'll make it 7. That way we might get out of here a little bit early, possibly.